Are we live? Okay. Bismillahirrahmanirrahim. Hello there. Assalamualaikum and a very good afternoon. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with EDD Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let us start our session with a recitation of Kitab Al-Fatihah. And for the non-Muslim, please recite your prayers according to your religion. Amin, amin ya rabbal alamin. So how is everyone doing today? I hope all of you are fine. Is everyone ready? Eager to start our physics class today? If so, you are all awesome and you are all superb. Thank you for joining our class today. But before that, I am Cikgu Zana, your moderator for today's class. And together with me in the Conti, our control host, Teacher Hapsa Ayu. Teacher Hapsa, hi. Teacher Hapsa, hello. Okay. Okay, right. And then we have our observer, Teacher Sue. Hello, Teacher Sue. And of course, the most important person of the day is Madam Rosmaya binti Mokhtar, our presenter for today. She is from SMJK Yuhua Kajang, Selangor. Madam Rosmaya is a very experienced physics teacher. So students, you are very, very lucky because we are very fortunate to have her as your physics tuition teacher. So for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya, please subscribe to her channel for her hard work in preparing today's lesson. Okay, students, don't forget to subscribe her channel. So as usual, this lesson will last approximately for 1 hour. So please follow the class until the end and give your full cooperation to make the class a lively one. But please take note, the certificate link will be given at the end of the class. And also, don't forget to claim your credit for today's live. And please collect the credit and redeem it for all the amazing, superb, attractive prizes in store. Rugi kalau tak claim. So claim. But however, students, please be alert because the code to claim the credit will be given 1 digit at a time. So you have to listen very carefully. Madam Rosmaya will give you the code, okay, as a sign of appreciation for your support to Madam Rosmaya. Okay, so get ready with your pen and paper. So, okay, class. All right. I would also like to remind students, okay, this is a serious note, to use appropriate language and also profile picture, if possible, your own picture so that we know you. If you wish to post comment on the chat box. I'm pretty sure all of you students, physics students out there are excellent students who will uphold a positive classroom environment. Okay, students, stay focused, listen carefully, and if you have any questions, do not hesitate. Please write on the chat board. And Madam Rosmaya will try her best to answer your questions. So, without wasting any more time, let's call Madam Rosmaya. Up to you, Madam Rosmaya.
Okay. Hi everyone. I am Madam Rosmaya. So I will put my slide. Okay. So before we start, okay, I would like to say the first announce the first code. Okay, the first code for the today's tuition class is number 9. Okay, number 9. So jot that down. And wait for 3 others code to complete the 4 digits of code. Okay. So this is my slide. Okay. So this is my channel. Okay. My full name, Rosmaya binti Mohtar. Okay. Then, this is our other team. Cikgu Hapsayu, Cikgu Ayu, kalau Cikgu Ayu is with us here as a control host. Okay. And then we also have Cikgu Su, okay, Teacher Su. Teacher Su is also here in our Conti with us as an observer, okay. And then we also have other three teachers, Teacher Suhaya, Teacher Rashida, and Teacher Nun, okay. So all are physics teachers, member in Academy YouTuber. Okay. So we also have other teams, the maths team led by Teacher Im, and together with us here is Teacher Zanaria, okay, with us today as our moderator. Okay, just now, below under me, okay. Then we also have biology team, okay, led by Cikgu Faiza, and then chemistry team led by Cikgu Shahnun, and also perakaunan dan ekonomi led by Madam Fizi. So all these are our team in Academy YouTuber, the pre-U physics, the pre-U and esteem and matriculation subject. Okay, so next. Okay, so without further ado, we start our discussion now. Continuation from the last topic, part 1, okay, magnetic fields due to currents. So part 2 for today's discussion. So we have discussed the Mps Law, okay, last week, and we have derived the magnetic field of straight wire. And today we are going to continue with circular coil or circular loop, and also solenoid. Okay, so we've done this one, okay, the straight wire and also the circular loop. So next is for the long solenoid. Circular loop first, circular loop. So this discussion, we will discuss these two topics. Okay, how to derive this formula? Okay, B equals to mu naught Ni per 2R. So B is the magnetic field, magnetic field strength or magnetic flux density. Mu naught is the permeability of free space. Okay, N is the number of turns for the coil here, and I is the current, and R is the radius of the coil. So we are going to prove this formula for the circular loop given here. Okay, for the single loop, N is for number of turns of the loop. So for a single loop, the B will be equals to mu naught I per 2R, where N equals to 1. Okay, imagine this is a single loop. Okay, so using the grip rule, right hand grip rule. So where is the magnetic field direction inside the loop here? As you can see here, the sign, the other finger shows out of the screen, out of the screen. Okay, for this loop. So this is the magnetic field direction for the loop. We observe from the top view. We observe from the top view. So at one side here, okay, if you grip one side of the coil here, so you can see that the magnetic direction of the magnetic field, okay, can be at any point here along the circle. Circle. You can see if we can see from the top view of the circular loop here. So this means that the element of length is along this circle, along this circle, which is equals to the diameter of the circle. So according to the Mps Law, this one is you see from side view. Side view, this one is on top view. So side view you will see like this. Okay. So from top view, also the same. So the element length of the direction in the same direction as the B, also along the diameter of the coil. And also at the other side, if you grip the other side of the circular loop here, so what happened? The element length also is in the same direction of the B, parallel to B. So from the Mps Law that we have discussed last week, okay, so the total of the B parallel to the element of length L is equals to mu naught I. This is a statement for Mps Law. So the total will be P times the diameter of the coil. Element of the length is diameter of the coil, which is equals to 2 times R. R is the radius of the coil. Okay, so equals to mu naught I, because this is Ampere's law statement. So we get B equals to mu naught I per 2R. So it is proven that for the single loop, the B equals to mu naught I per 2R. So for N loop, so you will get B equals to mu naught Ni per 2R if we have N number of loop. Okay, like given in the diagram here, if you can imagine. Okay, so done for the derivation part. So next we are going to use this formula. Okay, how to use this formula? Magnetic field strength for a circular loop. Okay, memorize this formula. B equals to mu naught Ni per 2R. Okay, so before we go to the question, the actual question using B equals to mu naught Ni per 2R. Okay, so this is a warming up exercise for you all. Okay, who can answer this? Where is the direction of the magnetic field? Who can answer this? You can write there in the chat box.
Okay, students, please answer Madam Rosmaya. Is A, B, C, D, E? Choose one.
This is a warming up exercise. Okay.
Yes.
So which direction? I just want to test you. How did you alert or not? With what we've discussed before. So this is the warming up question. So anyone can answer? So
Please,
use your what? So to measure the magnetic field direction, so what are you going
there's
to
an
do?
answer there.
Okay.
Amit Salim say A.
Okay.
Gao Mincai B. Gao Mincai B.
Okay. Okay, so there are two answers here given, A and B. So
B,
which
yes.
one is the correct one? Which one is the correct one? So be careful, your right hand grip rule. When you use right hand grip rule, so make sure the direction of the thumb is which direction? It's the direction of current, right? If it is the direction of current, so therefore this is what is moving around the circle in the loop here is electron. Okay, this is electron. So that means you must position your thumb to the opposite direction. Okay, so you will get out of screen. Okay, not? So position your hand like this. Okay, the thumb shows direction of current. The thumb actually shows direction of current and also the positive charge, because current, another word, is the flow of positive charge. So this given in the diagram here is the flow of electron. So you must be very, very careful using the right hand grip rule. Okay, must be very careful. So it's upward direction actually your thumb. So therefore the rest of the fingers shows direction of the magnetic field B, okay, which is out of the screen. So the correct answer is B, okay, out of the screen. Okay, no? I hope you understand. So that's why I purposely show this question for you to answer so that you can alert next time. Your right hand grip rule, your thumb is the direction of current. So if given electron, you must make it opposite. For the B direction is out of the screen.
Okay. Ben also answer B. Ben.
Okay, very good. Those congratulations to those who answer B. Okay. So we go to the next question. Okay, so a narrow coil of 30 turns has a radius of 16 centimeter and carries a current of 5 ampere. So find the magnetic field strength at the center of the coil. Okay, now it's time for us to use the formula just now we have derived. Can you all still remember the formula we derived just now? Okay, so try and do.
Okay, so please try, student.
This is direct question only. Only to test whether you can remember the formula we derived just now. Okay, what is the formula? So those who still cannot remember the formula, so I give here. So memorize the formula because we just derived just now. Hopefully you memorize. After this, bear in your mind this formula. B equals to mu naught Ni per 2R. Okay, so what's the answer?
Anybody write down the answer? Can write down the answer
Okay, the
on the
formula
chat
is given
box.
already. So you
Yeah.
just need to substitute the formula, substitute the values into the equation. Okay, Gamin Chai. We get
Yeah,
Gamin Chai.
government chai.
So 5.89 times 10 to the power of negative 4 Tesla from Gamin Chai. Okay. Okay, Sinue also the same, got same answer. So those who get same answer can just write same answer. Okay, so now let's check your answer whether it's correct or not. So mu naught value also we have discussed before. It's 4 pi times 10 to the power of negative 7 Henry per meter. So if your calculator, it will show 1.26 times 10 to the power of negative 6. So this is in terms of pi. And then the N, we have 30 turns, okay. Then I, 5 ampere. And lastly, the radius, don't forget to convert to meter. 16 centimeter, convert to meter, so you get 0.16 meter. So all must be in SI unit. So the answer is correct, 5.89 times 10 to the power of negative 4.
Okay, good student.
Okay, so let's go to the question becomes harder and harder. So let's try this question together, discuss. This time we are having two coils, two coils. So the figure below shows two loops, two loops, named as loop 1 and loop 2. So arranged coaxially. So what is meant by coaxially? So they are arranged like this. They have same center, They have same center. And on the same plane, they are on the same plane. So loop 1 has 30 turns, okay, with radius 40 centimeter and carries a current of 2 ampere in a clockwise direction. So the purple loop, colored here, the purple loop. So clockwise direction. Whereas the loop 2 has 25 turns and with radius 30 centimeter and carries a current of 4 ampere. And the direction is clockwise direction of current, clockwise direction, shown by the blue loop here. So find the resultant magnetic flux density or magnetic field strength at the center of the two loops. Okay, now we have two loops. So each of the loops will provide the magnetic field. So that's why we are going to determine the resultant magnetic field. Okay, or the net. Some questions say the net magnetic flux density. Okay, so you do one by one. We do for loop 1 and loop 2 first. Okay, so we do together lah this question. So for loop 1, we can forget the loop 2 first for a while. Okay, we are going to calculate B for loop 1 first. Loop 1. So can you still remember the formula? The formula, what is the formula? I cannot hear you, but you can say it to yourself. Okay, B equals to mu naught I per N, Ni per 2R. Okay, next we need to know the direction of the magnetic field. Okay, so you use a right hand grip rule. So you just choose one side of the loop. Let's say we choose this side and you grip the loop. Okay, so what you can see that the other fingers show at the center here is into the screen. That means the direction of B is into the screen. So shown by the red cross here. Okay, red cross here means direction of the B is into the screen. So using the formula, B equals to mu naught Ni per 2R. So we substitute all the values given for loop 1. Mu naught is 4 pi times 10 to the power of negative 7. So N is 30, okay, 30 turns. And I for the loop, first loop is 2 ampere. And the radius is 40 centimeter, so convert to meter. So you get a magnetic field for the first loop, which is 9.42 times 10 to the power negative 5 Tesla. Okay, the unit for B is Tesla. So we do the same for second loop. Second loop, the blue loop just now. And don't forget to write direction. So into the page, into the screen. Okay, for the for the second coil, the blue loop, we can forget about the purple loop just now. Okay, so use the same method, grip rule. Okay, the grip rule. So the grip rule, you can see that the other fingers show direction of the magnetic field out of the screen. So represent by the dot here. The B is out of the screen. And the thumb is follow the direction of the current. Okay, which is anti-clockwise. So that's mean then we can do find the B. Okay, so the B, you substitute the value of N given is 25 turns, okay, and the N and the I is 4 ampere, and the radius is 30 centimeter, so convert to meter. So we get 2.09 times 10 to the power of negative 4 Tesla. This is the magnitude, and the direction just now using grip rule is out of the screen. Okay, out of the screen. So one is in, one is out of the screen. One is into the screen, and loop 2 is out of the screen. So we have how the resultant should be. So the resultant is you minus them lah. Minus them. So let's say out of the screen will be positive. So into the screen will be negative. So this is the initial definition for us. If out is positive, into is negative. So you just write the out is now 2.09 times 10 to the power of negative 4 minus 9.42 times 10 to the power of negative 5. So you get positive. So your answer is positive 1.15 times 10 to the power of negative 4 Tesla. So what does this mean, positive? Positive, as we defined just now, positive is out of the screen. So that means your result here is out of the screen. So B is a vector quantity. So that's why you must write together with the direction. Okay. So Chia Chong get the correct answer. Okay. So if
Okay,
yes.
Madam Rosmaya, the second code.
The second code. Okay, so before we discuss the next question, okay, so the second code is, let me check.
Oh, sorry, the second digit. The second digit.
Got it. The second digit. The second digit is number 8. Okay, number 8. So jot that down. So we have 2 digits already. So the next 2 digits coming. So stay in our discussion until the end. Okay, so let's discuss the next question. The next discussion, okay, the question for circular loop done already for the 2 is very simple, so we just discuss 2. For more question, maybe we can do on another tutorial. Okay, so next we are going to discuss for B, for long solenoid. Okay, long solenoid. So B for long solenoid is B equals to mu naught Ni. So N here is the small letter. Small letter means is the number of turns per unit length. Number of turns per length. Okay, for the solenoid. That's why small letter. Okay, so we are going to derive this equation. Okay, still using the Mps Law. We are going to use Mps Law. So if you learn in the secondary school, how to show the direction of the magnetic field. So the magnetic field actually concentrated into a nearly uniform field in the center here, in the long solenoid. So the field outside here is weak and divergent, as you can see here. So how you determine this direction of the magnetic field? How you determine? So there are many methods actually. So one of the method you can use also grip rule, but this time with different direction. So direction of fingers will show direction of current. Okay, whereas direction of thumb is direction of the magnetic field. So opposite from the coil and the straight wire, like we discussed before. And also you can put your position, your hand is whatever you can position like these two. It still shows direction of the current is all the other 4 fingers, whereas the thumb shows direction of the magnetic field. Okay. Also, you've learned before how to determine the direction of magnetic field using the we call this as easy physics. Maths also you got easy maths, physics also got easy physics, right? So can use the symbol of S and N here. This is one of your method. But we are not going to discuss this in detail. So we just choose one way to measure to determine direction of B. Okay. So using the right hand grip rule. Okay, so direction of current, and then B is this way. Okay, so now we are going to use Mps Law. So how are we going to use the Mps Law? So for Mps Law, we need to use the path chose. The path chose for the Mps Law must be parallel to the B. So therefore, the path we choose, okay, this is to what? To memorize, to recall the what is Mps Law. Okay, Mps Law states that for any closed path, so we must choose the path that the sum of the length elements delta L times B is parallel, magnetic field parallel to the length elements equals to mu naught I. So I is the current that enclosed by the closed path. So in mathematical form, we write like this. Total of B parallel to the element L equals to mu naught I. So the element L, the L we choose here, must choose the B where it is parallel to this B. So that's why we choose the, how we choose the path, we choose the rectangle shape. Okay, the path we choose is a rectangle shape. So that the B parallel can divide into two parts. So one side actually got two sides. Two side of B is parallel to the length here, B this direction, right? Parallel to the length of the path you choose. Okay, the closed path you choose. And then the other two side is perpendicular. So for perpendicular to the path, perpendicular path to the magnetic field direction will give you 0 reading. So we just choose the parallel one, which is equals to the length of the solenoid, L, length of the solenoid. So B times L. There are two parallel length here in the closed path here. So the top one, the B is 0. Can consider 0 because it's very weak. So the B outside can consider 0. So 0 times the length here will give you 0. So we have only inside here B, the stronger one, the B times the length parallel to B. So we have B times L. Remember, this is the symbol for total. For the perpendicular one will be 0 lah. We choose only B parallel to the element of length L. And then we equals to mu naught Ni if we have n number of turns, so times Ni. So we cross multiply, we get B equals to mu naught Ni per L, and N per L is N, okay? Number of turns per length. So proven the formula, okay, for the magnetic fields due to currents for a long solenoid. Okay, if you refer to certain books, you can also use integration form. Okay, you've learned in maths, at maths T. Okay, you can use integration form also. This means the closed loop you choose. So there are four means length, 4 kind of lengths. So divide into 4. And so you choose the A to B, which is parallel to L, okay? The rest will be 0, because B outside is 0, and then perpendicular is the, because this one is used, we choose B parallel to L. So what give you finally is BL, okay? So there are two methods. You can use either method to prove the B equals to mu naught and I. Okay, so done for the derivation part. So memorize this formula.
Can we take
I. Yes?
Can we take a break for a while for the advertisement?
Okay, so before we do the question.
You want to show the question first?
So let them digest first whatever we discussed for the B equals to mu naught and I. So we can take a break now.
Okay, right.
Iklan
Berita baik untuk semua.
Again, iklan please. Press once.
Okay, control host, iklan. Click one time.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay.
We are back.
You
So
are
over
back.
to you again.
Okay, thank you Puan Zana, Cikgu Zana. Okay, so we discuss, or I think I give the third code. Okay, so the third code before
Yes, the
we start.
third digit.
The third digit.
Yes, for the
So,
code.
okay, so the third code is number 2. Okay, number 2. The third code. The third digit.
Third digit.
Third
Okay.
digit. So one more digit to go. Okay.
Yes, one more digit.
So next we discuss the question. Okay. Before we discuss the question, another things you need to know. At the end of the two solenoid here, we have two ends here. It's it's weaker, right? And we are not going to derive why it becomes this one. It's equals to the half of the B of from the center. The center is, let's say the center give you B, magnitude B. For the magnetic flux density. So at the two ends here will give you half of B. Okay, half of B. So when you use the value mu naught Ni, so it's become half mu naught Ni. Okay? So this is another things for you to know. And then another one, if we insert a soft iron core, okay, or any types of material used to insert into the coil here. So we use, instead of using mu naught, because mu naught is the permeability of free space. So we use mu naught mu r, because mu r is the for the iron core here. So B equals to mu r mu naught and I. Okay, so it's not free space anymore. So we use mu naught mu r. Okay, so we go to the question. First question. Okay, as usual, it's a warming up question. Very simple, just the substitution values into the equation. But you need to memorize the formula first. So a solenoid has a length of 3.2 centimeter and consists of 90 turns of wire. So the wire carries a current of 1.2 ampere, and calculate the strength of the magnetic field at the center of the solenoid. Okay, so can try now, students. So determine what is given in the question and then the formula. Okay, any answer?
Just substitute into the formula.
Warming up exercise only. So those who still cannot remember the formula, so I give here, B equals to mu naught and small letter I. So mu naught and I. So what is N and what is I? N is not given, so you need to expand it. It's the number of turns per length. So any answer?
So far, not yet. Still waiting.
Okay. So this time, if you realize the question
Okay,
states
there's one answer from Gao Minchai, 4.24 times 10 to the
4.24
power.
times 10 to the power of -3. That's very good. Together with the unit. Direction unit, because not given diagram. Okay.
Jiaji, there's Jiaji,
Okay,
Sing
and
Sing
Sing
Yue.
Yue.
Sing Yue.
Okay, so let's check your answer. Okay, so using n must be n per L, number of turns per length. Okay, expand this n because not given the small letter n. So substitute all the values given here. 90 turns, current already in SI unit 1.2 ampere, and the 3.2 centimeter, 0.032 centimeter. So do you realize that the B state here is strength of the magnetic field? Sometimes it can ask you as a magnetic flux density and sometimes strength of the magnetic field. So it's the same thing actually. So it's 4.2 times 10 to the negative 3 Tesla. Is it the same? Okay. Same as 3 of you answer. 4 of you given the correct answer. Congratulations. Okay.
Yes.
Okay, so you given three significant figures, so it's okay, still accepted 3 significant figures. So the information given all in 2 significant figures, so you may answer one step higher. So it's not like maths. Maths must answer in 4 significant figures, but physics no. So you must follow the significant figures of the information given. Okay, let's try now the question 4. Okay, question 4. We read first the question. The current through a solenoid is 2.0 ampere. So how many turns per centimeter must be wound on the solenoid in order to produce a magnetic field of 2.0 times 10 to the power of negative 3 Tesla within it? This time we are going to find the number of turns per centimeter. Okay, so try now. So what's your answer? Okay, hopefully you didn't make careless mistake for this kind of question. Be careful with what the questions want. The current through a solenoid is 2 ampere. So how many turns per centimeter? So that's mean the questions want n, right? Small letter n to represent the number of turns per centimeter. The questions want n. So actually question I gave today is in the description part. You can always check there whenever our class online live. So you can check in the description for the questions given. Okay, any answer from you?
Okay, there's one by Chai Teng Zuan.
Okay, thanks. 8 turns per centimeter. Okay, so got unit there, turns per centimeter. Very good. What about the rest of you?
Gao Min Chai.
Okay, 7.96 turns per centimeter. Okay, so now let's check. Okay, so from B equals to mu naught and I. Okay, so we are going to determine N, right? So we put N as the subject and the rest we bring to the right side, become B per mu naught I. So substitute all the values given, B, and then the 2. Okay, so you get 796 turns. So because it is SI unit, Tesla is SI unit, ampere also SI unit. So the number of turns also must be in SI unit per meter. Okay, very good. Who just now? Che Chong and Sinwe or Valamati also. Very good, all of you. You alert with the unit. Very good. So the unit given here is per meter, but the questions one. Per centimeter. So you convert to centimeter. So very good. So it's 8 turns per centimeter. So number of turns you use one digit, one whole number. So for number you write in whole number. Okay. So the best answer is 8 turns per centimeter. Okay. Okay, so we go to the next question and the questions become harder and harder. Okay, so this time a solenoid is made by winding 500 turns of wire evenly along a 20 centimeter long tube with radius 1 centimeter. And what is the magnetic field at the center region of the solenoid? Far from ends, means at the center here. Okay, if the current in the wire is 10 ampere. Okay, so try and do this question. This time, number of turns not given. Okay, so try to answer, students. So you are given the radius, 500 turns along
Yeah,
20
to calculate. Yeah.
seconds.
Have to wait for them to calculate.
Yes.
Oh, while waiting, can you give that 3 digits already dah? Is it?
I think the third digits. Okay, I can give the third digits, and it's a suitable time also for me to announce. So while waiting for you all to answer this question, I give you the third digits. The third digits is given already.
Given already, I think.
Given already.
9
The fourth one will be at the end lah.
at the
Okay.
end.
At the end better.
Yeah, they're still calculating.
It's not hard actually. Just the question purposely make you confused with the radius given. That's all. So by doing a lot of exercise, can reduce your careless mistake made during exam. Okay, so do practice make perfect, right? So you must do a lot of exercise. So today we can do together.
Okay, there's one answer from Gao Min Chai, 0.031.
Okay, 0.031 Tesla. Okay, so the rest of you can check your answer together. We do together now. B equals to mu naught Ni. So N is number of turns per the length given already. Okay, so we just substitute the values. Okay, 10 ampere, and actually the radius not even used in the question. So the answer is correct, 0.0314 Tesla, but the question give you in one significant figure, 2, so you must write in the 3.1 or 331 millitesla also can.
Linjian. Okay.
But you all didn't state the direction. Okay, direction. So direction. So remember, this time diagram is given. So if diagram is given, so you must put that direction together. Okay, so don't make this mistake. So if diagram is given, you must put together with the direction. So using a grip rule, okay, right hand grip rule. So the dot here means it's out, current. Direction of the 4 fingers here is current, so it's out of the screen, and then the other side is into the screen. So you grip the solenoid like this. So the direction of the B shown by the thumb. So that means it's to the right, to the right. Okay, so don't forget the direction, and the unit Tesla, 3.1 Tesla. The best answer is 3.1 Tesla to the right. Okay. So next. So now the question, next question, quite long. A solenoid of length 15 centimeter consists of closely spaced coils of wire wrapped tightly around a wooden core. So the magnetic field strength is 3.3 millitesla inside the solenoid near its center when a certain current flows through the coils. So if the coils of the solenoid are now pulled apart slightly, so you pull the solenoid slightly only. So stretching it to 19.2 centimeter. So why slightly? Because we are going to pull it without appreciably changing the area of the coils. So area of the coil, cross-sectional area of the coil, so doesn't change. So what does the magnetic field become near the center of the solenoid when the same current flows through the coils? So give your answer in millitesla with 2 decimal places. Okay, so how are we going to solve this question? So we do first. This is a diagram not given actually, but I shown here to show you for you to be able to imagine how it is done. So you stretch the solenoid at a certain distance without changing the area, the cross-sectional area, okay, of the solenoid. So that is what is meant. So means the area is constant. So using the length here, this is the initial length, okay, given. Let's say we call this L1 for the initial length. So the magnetic field, initial magnetic field given is B1, 3.3 millitesla, okay. And this is the second situation after it is pulled, okay, L2. Okay, then we are going to determine the B2. Okay, this is what we are going to determine, B2. So we are going to form two formulas because we have two situations. Okay, it is understood that the same current flow through them. Same current flow. So we form two equations. B from the B equals to mu naught Ni. So N is the number of turns per length. Okay, so this is the same solenoid, right? So N will be the same, current also the same. So that means B is inversely proportional to L. Okay, so you can use variation method. In this case, you've learned in form 4, form 5, right? Mathematics, the variation topic. So B is inversely proportional to L. So you can form the equation like this: B1 per B2 equals to L2 per L1. Okay. If directly proportional, will be B1 per B2 equals to L1 per L2. Okay, so for inversely proportional, you can write the formula like this: B1 per B2 equals to L2 per L1. Okay, use variation method. In maths, you've learned in form 4, form 5. Okay, so to find B2, you just cross multiply like this. Okay, then substitute the value. Okay, L1, B1 and L2. Okay, so you get the answer. But the questions one in millitesla, right? Millitesla. So you convert to millitesla, you get 2.58 millitesla, and in 2 decimal places, 2.58. Okay. This is one method. Okay, so another method, actually you can form two equation. It's the same thing actually. You form two equation for B1 and B2, and you can use ratio method. Simultaneous equation, can use ratio method, can use substitution method. Okay, then you cancel out everything, you will get the same formula like just now. So it's up to you to use which method. You have used this method a lot in SEM 1 already. So you get same answer, 2.58 millitesla. Okay, so for you to try the same kind of question, okay, try this one. Try this question. Okay, this is for you to try. Live with together. Okay, try now. Okay, can read together the question. A solenoid of length 15.2 centimeter consists of closely spaced coils of wire wrapped tightly around a wooden core. So the magnetic field strength is 2.2 millitesla inside the solenoid. Inside the solenoid, near its center, when a certain current flows through the coils. If the coils of the solenoid are now pulled apart slightly, stretching it to 18 centimeter without appreciably changing the area of the coils. So what does the magnetic field become near the center of the solenoid when the same current flows through the coils? Okay, so if you really concentrate on what we've discussed just now, you will be able to answer this question very fast. Okay, what's your answer? I'm waiting. Okay, so we have answer here. Lim Chia An, 1.9 times 10 to the power of negative 3 Tesla. Okay. Sinway also 3 significant figures. Chia Che, also Gao Ming Chai. Okay. So unit, very good. You don't forget the unit. Okay, so now let's check your answer. So we use the same formula. B is inversely proportional to L. So B1 per B2 equals to L2 per L1 because inversely proportional. So we are going to determine the B2. So B2 equals to B1 L1 per L2. Okay, substitute all the values. All this must be shown to get marks. Okay, so the answer is 1.9 times 10 to the power of negative 3. Okay, very good. So correct answer.
Yes.
Good.
Good.
You write in 3 significant figures, still accepted. Still accepted. Because the question information given 15.2 is in 3 significant figures. Here 2.2 significant figures. Okay, so you are allowed to write in 3 significant figures also. But the best is 1.9 actually. The best. Okay. So let's go to the harder one. The harder one. Okay, this time is different situation from the question 7 and 6. Okay, so we read first the question. The diagram shows two solenoids, X and Y, with the same length of 0.25 meter and made of constantan wire. Okay, so the number of turns and diameter of each solenoid are as indicated. So the first one, X, 150, and the number of turns, but diameter is 2 centimeter. But the second one, Y, solenoid Y, the number of turns is 100. Okay, and the diameter is 3 centimeter. So it's larger in diameter. Okay, so the cross-sectional area is larger. So when solenoid X is connected to a battery of negligible internal resistance, so the current in X is 1.5 ampere. So what is the magnetic flux density inside solenoid X? For the second question, find the magnetic flux density inside solenoid Y when it is connected separately to the same battery. So both of the X and Y, we use the same battery. Okay, there's a hidden information from here. So we do question A first. Question A very easy, just as the previous question we've done. So what is the magnetic flux density inside solenoid X? Okay, so you do this first. We do this together before we do the B part is the harder part. So A is very simple. So what is A? The answer for A. Can you do now? Okay, current is given 1.5 ampere. Number of turns for X is 150 number of turns. They have same length, 0.25 meter. Okay, so what's your answer?
Yes, student, we are waiting.
Okay, so very fast you can get actually Gaussian 1.13 millitesla, right? Okay, so let's check your answer. So it's correct, 1.13 millitesla. Okay, now we go to B part. B part. So find the magnetic flux density inside the solenoid Y when it is connected separately to the same battery. So what does this mean, the same battery? So that means the same voltage, potential difference across the V here. So from we are going to determine the By. So By equals to mu naught Ny Iy. So what happened? The current is no longer 1.5 ampere like just now. Because yes, correct. Because the same battery potential difference is the same, but the current will not be the same. Okay, the current will not be the same because the resistance here is different from the X. Okay, the problem is the I. We are going to determine what is I. So the rest, no problem. Mu naught is 4 pi times 10 to the power of negative 7. N is N per L, so 100 per length given, the same, right? Given, same length, so 0.25. So now the problem is the current flow through Y. So the current is not the same as the previous question we've done. Okay, because the area is larger now. So we are going to make use of the diameter given here. The first one, diameter is 2 centimeter. The second one is become larger. So the current won't be the same because of the resistance is higher here. So next is we are going to determine the I here. So we use V equals to IR, where V is same battery, right? So the V is constant. We assume negligible resistance for the battery. So we can use straight away V equals to IR. Okay, so we are going to determine I. So I is V per R. So V is constant in battery. So that means I depends on R. Okay, I depends on R. So I is inversely proportional to R. But R, we don't know R here. So if we don't know R, so there is another hidden information here. Constantan wire made of same wire. They are made of same wire. So that means we can use the R here as R equals to resistivity L per A. This one from the previous chapter you've described. You've learned in a previous chapter. So we can use R equals to rho L per A. Both have same resistivity because both made of constantan wire. Okay, so R no problem. Length also, length will be different because this one is larger diameter. So the A cross-sectional area of the wire will be the same because same type of wire, made of constantan wire, same type of wire. So then resistivity and A will be the same, but L won't be the same. This L, be careful, this L is not the length of the solenoid. This L is the length of the wire. So you must be really, really careful what is the R equals to rho L per A stand for. Okay, it's the resistance of the wire. It's not resistance of the solenoid. So resistance of the wire, so that means the length here is length of the wire. So you can make use of the diameter here to determine the length of the wire. This is not the same length of this number density here, number of turns per density. So different length. Okay. So now R is directly proportional to L because same wire and cross-sectional area. Same wire. Okay, so not this one. This L is not this one. L is the wire. Imagine you stretch this wire. If you stretch this wire until it become a straight line. So we are going to determine the length of the solenoid here, this part. Understand or not what we are going to use next? Imagine you stretch the solenoid until it becomes straight. So we are going to find the length of the straight white solenoid that we have been straightened to a long wire. Okay, to find the length of the solenoid here after you stretch it straight. So to find, we use the one circle, one turn. One turn means we assume there is a circle shape. So that's mean if you look from one side here, you will see that like this, right, is form a circle. So for one wire, we can say for one circle is equals to the length of 2 pi r. Okay, 2 pi r. So length for one turn is 2 pi r. But the wire, the solenoid here has n number of turns. Okay, has n number of turns, 100. So let's say n first, n. So for n turns, that means n times 2 pi r. So we have 1, 2, 3, how many hundreds? N turns of this circle. Okay, of this circle. So which is the circumference given formula is 2 pi r, right? So when you spread this, you will get this length. Length equals to n 2 pi r. Can imagine or not? Okay, I hope you all can imagine. Okay, then this is R. You can use the diameter here. R is diameter per 2. Okay, diameter per 2. So you can cancel the 2. So therefore, the length of the solenoid is equals to n pi d. Okay. So imagine the solenoid here, you stretch each to become a very long wire, and the length is equals to the n pi d. Okay. So now we are going to substitute into here. Okay, R is directly proportional to L. So therefore, R also directly proportional to this one, n pi d. And pi is a constant, so you can say that R is directly proportional to nd. So you can substitute into here. That means I is directly proportional to nd also. Okay, so that's why we get the I value. I is directly proportional. Inversely proportional. I is inversely proportional to R, right? So you can substitute here. You can say that I is inversely proportional to nd. Okay, so next, we determine the two situation here, right? So for Ix and for Iy is 1 per nx dx. So I is inversely proportional to ny dy. So you can form two equation here. So you can rearrange the equation to get Iy. Okay, not? So Iy is bring this up, cross multiply, bring this up. So you get Iy equals to nx dx per ny dy times Ix. Okay. So just use variation method. Use the variation method to get this. Okay, now you can substitute the formula, the information given. Okay, what is nx? For nx is 150. The diameter 2 centimeter convert to meter. And current just now 1.5, right? For Ix is 1.5. So that's for the y, 100 turns, diameter 3 centimeter convert to meter. Okay, so just substitute into the formula here. You derive this now for Iy. So you get the answer and substitute here, and finally you get the By. Okay, so quite a long solution here. Okay, so this is the answer. 7.54 times 10 to the power of negative 4 Tesla. Okay, so this is the final answer. Okay, so I think that's all for today's discussion. We can reach until question 8 only. So it's okay for the exercise. We can discuss in the future. Okay, maybe we can do tutorial on this topic. Okay, so that's all for me for today.
Okay, thank you, Madam Rosmaya, for the interesting lesson, and thank you for preparing for today's lesson. And congratulations to those students who are able to follow the physics class from the beginning till the end. So once again, students, as a sign of support to Madam Rosmaya and to thank Rosmaya by clicking the subscribe button if you are new here, okay? And please don't forget to activate the icon bell so that you'll be notified for the next class lesson. And don't forget, yes, hit the like button. Okay, then, okay, right. Type done first, and Madam Rosmaya will give you the last digit for the code today. Okay, type done. Oh, the link digit is out. Okay, Madam Rosmaya, the last digit then.
Okay, so the last digit is 1. Okay, 1.
Okay, the last digit is 1. So she has given you all the 4 digits, so make sure you claim the credit, okay, for today's live class. This is as a token of appreciation for joining the class today. Right, please, the link is already in the chat box, so please take note, the certificate link will end half an hour after this live. So make sure to use EDD email only to log in. Incorrect email use will not be entertained. So if you wish to get more information on the online classes, you can always go to www.academyyoutuber.com. And for those who have not joined EDD Junior Telegram, please do so. So I would like to thank all of the students today. You have been so wonderful and you have been very responsive. I'm so happy to say that. Thank you for being an IU supporter. You are very, very awesome. Okay, feel free to share this free tuition class with your friends and teachers all over Malaysia. Remember, this is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So don't forget to join the next class, physics class, on Sunday at 5. And the lesson will be on, teacher, Madam Rosmaya? Next lesson will be on what?
Next lesson.
The same topic, is it?
No, force between the two current carrying conductor.
So please take note, stay tuned for next week's class. So till we meet again, ingat hashtag, bermula percuma, selamanya percuma. Stay safe and be safe, students. Bye. Assalamualaikum.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
Alhamdulillah.